All right, what's the first one? Hot cocoa, is that what it says?
Yeah.
Who wants more time on that first one? Who needs more time on that first one? We okay to talk about it as a class now then?
Yes.
All right, so. At this point, I want you to go, hot cocoa. What's in hot cocoa? What's the thing you should the most of?
Sugar.
Water, right? Water. You drink it, it's got to be water. Okay. So, next, maybe sugar. Next, what else? Cocoa powder. Okay. I'm going to tell you a quick little story, all right? This is a story about a concern that kind of came about many years ago about genetically modified foods, right? People were trying to poll the country and find out how much concern was genetically modified foods. And so they said, do you think, one of the questions was, do you think that it's critical to label the outside of foods that are genetically modified with this food has been genetically modified? And what percentage of the world, or the United States, do you think said, yes, that's critical? When was this? It was about, maybe about 5, 6 years ago now. So the answer was like around 55%. 55%. Okay? And then they asked another question. Do you think it's important to put on the outside of food whether or not food contains DNA? DNA. So you guys have a rough idea of what DNA is? Have you heard of that? Heard it on TV shows maybe? DNA? What does it stand for? Anybody know? All right. And what percentage do you think said, yes, that's critical information? More or less than 55%? More. More than 55% said it's critical that I tell people whether or not there's DNA in food. What does that represent? A disconnect, right? A clear misunderstanding of what genetic modification means and what food. I mean, can you think of a food that we eat that doesn't have DNA? I'm sure there's some out there that are hard to think about. Does cocoa have DNA? Yeah, if you're taking anything that's living, grinding it up, it's similar to taking people, grinding them up, and then having the same type of stuff. It'd be very hard to differentiate in terms of the kinds of elements you have, right? Because this is some living organism when you're grinding it up. So does cocoa have DNA in it?
Yes.
Yes. Cocoa has sugar, cocoa has proteins, all the proteins that are going to be in that organism. All right? Maybe it's not very much because we're not interested as well. Okay, so clearly it can't be a pure substance. Can't be elemental. All right? Oh, what else is on our list? What must it be, I guess? A mixture of some sort? What do you think? Is it going to be heterogeneous or homogeneous? Homogeneous mixture? And to me, it really doesn't matter whether you put homogeneous or heterogeneous. That you identified that it's a mixture is what's most important. I think from a chemist's perspective, we have to say it's probably one. A heterogeneous, what's the word again? Suspension. A suspension. Okay. The next one. Did we get to the next one yet? Anybody want time to work on the next one? Raise your hand if you have time to work on the next one. Okay, what's the next one? Is it flour? No, what is it? Ice. Nice. Nice ice for sale. How much is it? There's another one. You do? Nice ice for sale. Nice ice for sale, 10 cents a pay. That's Dr. Seuss Ryan. Reads my kids all the time. All right, so ice, a mixture. Not a mixture, right? Don't look, don't look. Is it a compound? Yeah, I heard somebody say a compound, right? It's got to be a compound. Is it an element? Yes. Element. What does an element mean?
Pure.
Is It's a pure, well,
Or pure.
water can be a pure substance too, but it's all the same element if it's an element. So it's not like that. Okay, but yeah, I think it's a compound, right? How about a molecule? Is it a molecule?
Yes.
Yeah, how do we know that it's a molecule? What was our test? It doesn't contain a metal. That's right. So we said that all of our compounds could kind of, in a way, be broken up into molecules or ionic compounds. And we said these ones would most likely contain metal, and these would have no metal. And, for those who first time, the metals can be identified from the periodic table using the green staircase. See this green staircase there? The left side, those are all metals. The right side are our small group of non-metals, with hydrogen being an exception, top left. Okay, so water contains hydrogen and oxygen. Both of those are non-metals, therefore water is a molecule and not an ionic compound. I think we got them all, right? Did we say pure substance? I don't know if we talked about that one, did we? Is it a pure substance? Yeah, right? So what is the definition of a pure substance? What are the things that can be pure substances? Or what is this broken into? Pure substances can be broken into compounds or elements. All right? So sometimes when people hear the word mixture, they think, oh yeah, mixture is where you mix different elements together and make something. No, that's not a mixture. Okay? I mean, you know, in some houses it might be, but in the scientific world, a mixture is not mixing elements together. It's it could be mixing elements together like this, right? Did we talk about this being a mixture? Did we talk about that or no? If I tell you this is a mixture, then how many carats does it have? You know, like, well, less than 24, right? 24 karat gold was 100% gold, so. All right, so a mixture meaning is 10 karat, 14 karat, I don't know exactly, but it means it has some other stuff in it. And that's why it's got its rigidity, right? Okay, so mixture means combining either multiple elements or multiple compounds together. Okay, any questions about that? So water is a pure substance. White flour, did everybody get a chance to approach white flour yet? Anybody want to start to do this one? I want you guys to discuss this if you haven't had a chance to discuss this. Nobody needs time to discuss it?
We do.
Oh, great. 48 seconds. Ready? Go. If you've already done this one, and you've already done all of them, here's another one you can work on. Here's a couple more if you've already finished. Automobile gasoline and tin foil. All right, let's talk about white flour. What do you guys think? We're on white flour, right? Yeah. What do you think? Is it a pure substance? Okay. So if it's a pure substance, then it must be either a what? Compound or an do we make white flour? We take people and we grind them up, right? It's little tiny people, and they're little, some people call them wheat, but they're still people. Person's a person, no matter how small. Look, we've got so many different Dr. Seuss things going today. Okay, so is it going to be a compound? If you homogenize a person, does that turn it into a compound? No. Right? Is that confusing? Yeah? So I got this person, all right, and I'm going to grind them up and make them into sauce. It doesn't turn all of their elements and molecules into one thing. It just makes them homogeneous. True? All right. It's not a real person. It's a piece of wheat. But I grind it up really fine. What's in there? What's inside that flour?
Hair.
What?
Hair.
Hair?
Hair.
Air in the flour? What's the primary thing in flour? Well, wheat was what we got the flour from, right? Or protein, is that what you guys are saying? There's some protein in there? What else is there? Wheat is a seed. So what kinds of things do seeds need to?
Carbohydrates.
Carbohydrates. Lots of flour, lots of sugars in there so that the new seed can grow without anything to start off. So we got lots of sugars. Sugar is going to be carbohydrates, sugars, glucose, all of that, which is the same category, and in this class, basically all the same thing. We're not going to have very many conversations where we get to delineate all the differences there. That's all right. We're going to display like this, C6H12O6, which is basically glucose. Okay? So anytime we talk about or reference sugar in this class, we're referencing glucose. This is the unit that our body utilizes, right? We eat mostly sucrose, right? That's our table sugar. It's a package of glucose with another package of fructose. So we know a lot about carbohydrates, but we're not going to explore that here. Is whenever we talk about sugar, we're generally going to be thinking about molecule of glucose. All right, so we definitely got mostly glucose in our wheat, right? Flour. Anything else? Is there DNA in there? Yes. Are there proteins? Yes. Everything to make the living system work are all in there as well. So, we got a mixture, right? We got a mixture. Is your flour, your white flour, homogeneous? No? What does yours look like? Okay. It could be. It could be. It could be homogeneous. I mean, if you make it the way that my family used to make it, we grind, it's still kind of grainy, and some parts aren't as grainy, so I wouldn't call it homogeneous. But I think the stuff you buy at the store would probably be a homogeneous mixture. Okay? Is that all right? Everybody understand how that works? How about sodium chloride? Anybody want time to work on sodium chloride? All right, so pure substance? Yeah. Element? No. Compound? Molecule? No? Why not? Because it contains a metal. Very good. So it is a compound. There's no spotting here for ionic compounds, but it's an ionic compound. Okay, very good. Pure substance compound. I had these other ones up here. Did you guys see these? Automobile gasoline, tin foil. What do you think? Automobile gasoline? Which one would it be? You think it's a molecule? Hmm? It has what? Metal? Oh, well, I mean, it depends if you're talking about leaded or unleaded gasoline, I guess. But that right there indicates to you something about this stuff, right? It's a lot of stuff in it, right? In fact, on the gasoline that you go buy nowadays in Hawaii, and I'm pretty sure in the mainland, this gasoline may contain up to 10% ethanol. All right, so there's something else in there, ethanol. Do you guys know any other things that might be in gasoline from your
Or like detergents.
Life history. Detergents, they tell us about that on commercials all the time. Anything else? Hopefully not much water, but yeah, in the tank, you might get a residual amount of water that condenses and stuff. And that's a problem, right? That's a problem. And it's interesting, we talk about a mixture of water and gasoline. Do they mix? You know?
No, it's oil based.
Okay, because yeah, it's like oil, right? Here it is. If I combine a container that has water and gasoline, it layers like oil and water. What would be our top layer, do you think? Gasoline? Okay? This is critical for a scientist at any level to become familiar with, right? And the way that I hope that you can always remember, I'm playing a game, I'm drawing something. Can you tell what it is? It's a boat, that's right. And on this boat, right now there's a little hole in the boat. And out is coming the what? The oil. It's leaking oil. Where does this oil go? It floats. It floats. So remember, when there's an oil slick, it floats on top of the water. So that'll help us remember that the oil is less dense than the water. All right? And gasoline is essentially a short chain, what we think of as oil. Right? And the word that I was hoping that you might have some familiarity with is octane. Octane. Who's heard that word before? Octane. Nobody, or not very many, huh? So it's called, you look on the side of the gas pump, and you can see there are different octane ratings for what you're buying. And sometimes 89, 87, 85, right? Different octane ratings. And octane refers to kind of the thing in the gasoline that's really giving you your power. And that's what we'll think about when we're talking about gasoline. Okay, so this was our sugar. This is our octane, C8H18. We'll talk more about that in the future. All right, so it is going to be a mixture. What do you think? Homogeneous or heterogeneous? Homo? Yeah, it better be. If it's not homogeneous, what would that mean about when you go buy gas?
You don't need to less than separate.
Every time you're going to get something different, right? And that's not a way you can run a machine. You can't always be given different things and expect it to be able to perform the same way all the time. Okay, how about tin foil? This is one I learned just this past year. Any suggestions for which one of these tin foil might be? I mean, it doesn't need to be a right or wrong answer. What are your thoughts?
Like store-bought tin?
What's that?
Is it store-bought tin?
Yeah, store-bought tin foil. Or I guess, so you're suggesting that if I bought it from someplace that said tin foil in quotes, as opposed to underlined twice or something, or like
Or like, if you have made tin foil, you have tin, there's like store-bought tin, and foil has like wax or something on one side.
okay, all right, okay. I don't know if there's wax. Is there wax on tin foil? I don't know.
Size is bigger.
One side is more shiny.
Yeah, one side.
One side more shiny.
Yeah.
Okay. So, if I just got rid of the foil part, then it must be what? Pure substance? Anything else up there? Element. Is tin up there on in terms of an element? Which number? 50. All right, it's there. Okay, good. Compound? No. It's just one element. That's it, that's all. Right? Everything there's tin. Now, what I learned over this this year is that tin foil actually has a certain amount of other stuff in it, which is very interesting because, well, not looking into it, it's a very small amount, and it might differ from foil to foil, but we can play with some. So if you're talking about that sort of scenario, then we move away from pure substance and element, and if it's a metal, it's not really compound anymore. So you're looking at probably a homogeneous mixture. All right, good talk. Okay, so let's think about physical properties versus chemical properties. Physical properties versus chemical physical reactions versus chemical reactions. I feel like we didn't talk much about that before. Did we give any examples of physical reactions and chemical reactions? Okay. So let's look at some physical properties here. Boiling point, melting point. These things all are kind of fixed for the specific substance that you're dealing with. Right? If I had a piece of ice, it would have a given melting point, a given boiling point, resulted in went to water. Right? Whereas a chemical property has to deal with how that ice would react with something else. Okay? You can identify a chemical reaction because the products of the chemical reaction will have the atoms interacting with each other in a different way. So, for example, if I have this chemical and it does this sort of thing, we have these atoms interacting together, and now they're separate. If I do this sort of thing, where I have water, which is liquid, going to water as a solid, there's a change. What is that? Did you catch what that L was? What did I say? Liquid, solid. There's a change, but it has nothing to do with how the atoms are interacting with each other. Okay? What do you call that process where you go from liquid to solid? Freezing. So that's an example of a chemical property or chemical reaction and a physical reaction. All right. So what do you think? Magnesium metal is gray. Chemical or physical? Crawford, what do you think? Why don't you guys look at the previous two lists on that slide and help your partner fill in, put a check mark in all the appropriate spots for these four problems. Okay? Go for it. I'll be right back.